Hi everybody, and welcome back to another General Chemistry 1 video. So today I'm just going to be going over some of the basic concepts that you need to get started on your post-lab for Thermochem 2. Don't worry if it seems like a lot, it is some harder concepts. Hopefully you got over them in lecture, and you also have your TA. Be sure that you're staying in communication with us. So the first thing that we need to talk about is endothermic versus exothermic reactions. In endothermic reactions, you have the system requiring heat in order for the reaction to proceed. So here you will see heat is going into the system. It is endothermic. You can tell an endothermic reaction is happening because if you touch the test tube that it is happening in, it will feel cold to the touch because heat is leaving the surroundings and going into the system. The second kind of reaction is exothermic. That is when we have heat being released from the system into the surroundings. So our reactions last week with Thermochem 1 were all exothermic because heat was leaving the spirit lamp and going into the water, which was our surroundings. Remember that from last week, our heat of the reaction is equal to our Q, and our delta Q is equal to our change in enthalpy, or our delta H. These are concepts that can get a little tricky once you are going through them. Khan Academy has some really great resources, plus you have TAs who are sitting at home waiting to answer your emails. All right, so the next part of this recitation adjacent type of thing is we're just going to talk about our procedure a little bit. So we use our calorimeter. The reason that we use this calorimeter is because it allows us to measure the temperature of the reaction and ignore the temperature of the environment around us. So it contains it and we can make better, more accurate calculations. You need to make sure that you understand that the units that we are doing this entire post-lab in are calories. A calorie is the energy it takes to raise 1 gram of water by 1 degree Celsius. 1 calorie is equal to 4.184 joules. That is your conversion factor. That might sound like a familiar number because 4.184 is also the specific heat of water. This is the specific heat of water because the specific heat is the amount of energy it takes to raise 1 gram of a substance by 1 degree Celsius. The last thing I want to talk about over here is that you have to use your data, the final temperature that we measured and the initial temperature that we measured. This is data that is given to you to find the delta T. This is going to be plugged into your Q equals MCAT equation. So we're going to head this way on the board. So we are going to be calculating the Q of the contents. When it says Q contents, this is the same as last week when we said Q surroundings. So our Q contents is equal to MC delta T. The first thing I really want to hammer home here when we're looking at this is that the mass you are using, we are going to make a couple of assumptions here in order to make these calculations easier. When you are using a solution, the mass that you are using, you are going to assume that the density of that solution is the exact same as the density of water. So if you use 50 milliliters of a hydrochloric acid solution, you are going to say that that was 50 grams of hydrochloric acid. Because we are making this assumption, we are also going to make the assumption that the specific heat of all of these reagents is the specific heat of water, so 4.184 joules per gram degree Celsius. We can do this because the solutions are so dilute that they are suspended in water, and therefore we can make those assumptions. So don't get super confused about it. If it is unclear at any point, go ahead and shoot us an email. The one place that this is different is when you are using a salt or a solid in the reaction. Those you will actually add the mass of the salt to the mass of your liquid solution as well. So just pay attention to what you're using. If it is a solution, you are going to assume that it has the same properties as water. All right, so the very last thing we're going to talk about here is some stuff that you need to know in order to do a couple of the problems. So problem 1B is a Hess's law problem. So for this one here, you have your delta H of reaction 2. That is going to be your hydrochloric acid plus your sodium hydroxide. Reaction 3 is acetic acid plus sodium hydroxide. We have measured experimentally, and then calculated the delta H of both of these reactions. This Hess's law equation tells us that reaction 1 plus reaction 2 equals reaction 3. Because we want to find reaction 1, you are going to have to rearrange this equation to set reaction 2 and reaction 3 equal to reaction 1. It will make more sense when you start going through your post lab, but this is information that you need to know. The final thing is that there is a problem where you are going to have to do your own Hess's law equation with the delta H given to you. So we have given you two equations here. We have given you potassium chloride and turning into gas phase, so a potassium cation and a chloride anion, and then from gas into liquid. So what you are going to do first is you are going to figure out what the final equation is here. So we did this before when we were looking at net ionic equations. Look for the anions and the cations and the substances that do not change throughout, that are the same on one side as they are on the other, and you will cross those off. And then in order to find the delta H of the total reaction, you are going to use Hess's law to add these together, and that gives you the delta H of your total reaction. If you have any questions about any of this, or you have trouble reading my handwriting, it should be posted somewhere else. If you can't find it, email your TA. Have a great day, guys, and we are almost done with lab for the semester. You guys have done great.